Let's have some fun with our multi-layer switches and HSRP. What do we want to do? We want to analyze the path that is currently being used by a PC within a particular VLAN. Right now, we have HSRP Group 10 configured on DSW1 and DSW2, and it's associated with the subnet of 10.110/26. On DSW1, the command show standby verifies this for us. DSW1 is currently the active forwarder for Group 10 based on interface VLAN 10. The virtual IP address being used is 10.1.1.62. Now let's make sure that that is the IP address currently configured on our PC. So we'll type in ipconfig, and when we scroll through our output and find it, it says right here, default gateway is 10.1.1.62. So the client's configured correctly with the virtual router IP address. And there's the MAC address of the virtual router's IP address. We will examine this after on the PC once we generate some traffic from PC1, and we'll see that PC1 truly learns this exact MAC address. So that will be the MAC address that's put in the frames that PC1 has to send to the default gateway. So the active router is local, and the standby router has the IP address of 10.1.1.2, and that is DSW2. If we go to DSW2 and type in show standby, we'll see that it is the standby router for Group 10. So let's trace the path right now on PC1 using the trace route command. And we'll trace route to 192.0.2.1, which is the internet. And let's just follow the path here. All I care about right now is that very first hop. The very first hop describes the router that we are going through. So that will be the default gateway. Who owns 10.1.1.1? Well, if we go back to our environment and we type in show IP interface brief pipe to include 10.1.1.1, we can clearly see that DSW1 owns this IP address of 10.1.1.1, and it's associated with interface VLAN 10. So the traffic is currently flowing from PC1 up to DSW1 and then being forwarded out to R1, R3, and then R4 if we go back and examine all the hops that are occurring in that trace. Now you might be questioning, well, wait a second. Why was the virtual router's IP address not returned? Well, the virtual router's IP address is not returned because it's not officially a hop. It's just this virtual IP address that's being utilized to represent the default gateway. And if that was the IP address that was returned in the trace, then we'd have no way to verify which router was being currently used as the default gateway or as the active forwarder. So this result of returning the IP address of the interface of that first hop allows us to verify that the active forwarder is who we intended to be. Let's examine the ARP cache. ARP-A. We can see from this output that 10.1.1.62 has this particular MAC address. So 00000C07AC0A. And we can confirm that with DSW1 that this is truly the virtual MAC address. So all of that's lining up perfectly within the environment. But what happens if we have a failure on DSW1? So let's simulate that failure. We'll go to interface VLAN 10 and we'll type in shutdown. So we'll just shut down interface VLAN 10, and as a result, the hellos will no longer be exchanged between DSW1 and DSW2, and DSW2 should now become the active forwarder, and it is. But wait a second, just because it's the active forwarder, is PC1's traffic correctly going through DSW2, or is it still going to DSW1? Let's verify that with a trace route, and we can clearly see that PC2's traffic is now successfully, or PC1's traffic is now successfully flowing through DSW2, 10.1.1.2. And let's return our environment back to its original state, so no shutdown. And because preemption is enabled on DSW1 and because it has the higher priority, it becomes the active forwarder again. DSW2 is speaking. It will then realize there's no other router that's the standby router, so it will move to the standby state. And if we go back to PC1 and we do our trace route, we can see here that we are now going through DSW1 again with the IP address of 10.1.1.1 being the very first hop.